दोस्तों, we have a very eminent professional here in our studio today, Mr. Rabindran Sundersingh.
ये ऊर्जा के क्षेत्र में पिछले 30 सालों से काम कर रहे हैं और रिन्यूएबल एनर्जी के मामले में बहुत अनुभवी हैं। इन्होंने भारत की कई बड़ी कंपनियों में काम किया है और अब अपनी फर्म अभी चलाते हैं एज एन एंटरप्रेन्योर। आज ये हमारे साथ बात करेंगे कि कैसे हम रिन्यूएबल एनर्जी, हाइड्रोजन और न्यूक्लियर एनर्जी की मदद से देश के जो नेट जीरो या कार्बन न्यूट्रल के जो गोल है उसको हम कैसे हासिल कर सकते हैं।
सर, आपका स्वागत है जीटी लॉग पॉडकास्ट में।
थैंक यू।
सर इज अ बॉर्न एंटरप्रेन्योर और आईआईटी मद्रास से उन्होंने इलेक्ट्रिकल पावर में इंजीनियरिंग की। तो सर, सबसे पहले तो हम आपसे जानना चाहते हैं कि एक अपने बारे में थोड़ा सा बताएं और हमारे दर्शकों को भी पता चले कि आपकी जो जीवन की जो स्टोरी है वो क्या है। और दूसरा, हम ये भी चाहते हैं कि जो शिफ्ट है, क्योंकि आपने इलेक्ट्रिकल पावर से शुरू किया और फिर रिन्यूएबल एनर्जी में काम कर रहे हैं, तो वो शिफ्ट भी कैसे हुआ।
Okay. Hello to everyone. Thanks for having me on this podcast. I studied electrical power, that's true, from IIT Madras. And I spent probably 20-25 years in the power sector, the hardcore industry like power generation, transmission, distribution, all kinds of generation, thermal, hydro, gas. And I was fortunate to begin my career with Tata Power Mumbai, because as many people may know, Tata Power, the Tata Group itself, was very fond of innovating. They always went for the latest products. For example, India's first 500 megawatt unit was set up by Tatas. It was at a time when everyone else was at 220 megawatt capacity. And Tata set up this 500. So many questions were asked. How can such a big unit function in this grid? What will happen to Bombay if this unit tripped? But Tatas did it and they succeeded. No, like this, they have done so many innovations. And I have benefited a lot. Even today, when people are talking of storage, home storage, I was part of the commissioning team, which commissioned 150 megawatt single unit pump storage in 1996. So you can imagine
1996 pump storage.
Yes.
Okay.
Almost 30 years ago.
Yeah.
Tata's had set up such a huge pump storage. So far side. So I was very fortunate there. Then, of course, I worked in a number of utility companies, private sector. I worked as in an EPC company, a large one, Reliance Infrastructure, where again I worked in so many roles. One was head of commissioning, the other I was heading core engineering. The last one I was heading the transmission division. So it gave me a lot of 360-degree experience in the power sector, in commissioning, in design, in operation and maintenance, in troubleshooting, in setting up projects, designing, and so on. And at which point, somewhere in 2013, I was beginning to look very seriously at renewable energy. Even in previous years, I had been watching wind turbines. At that time, they were of the order of 10 kilowatt, 15 kilowatt, 25 kilowatt, little things. And solar. Solar, of course, was in a very small scale. Interesting. The calculator that I used in IIT was purchased in 1984. It had a solar cell made by a company called Sharp, yes. The Japanese company. Even today, after 40 years, it's working. So the solar cell is working and the calculator is working. But yes, as I said, in 2013, I started having a very great interest in this. And I kind of self-taught. Because I was in a thermal industry at that time.
Right.
And I read up everything possible about this sector, solar, wind, what were the regulations, what is CRC doing, what were their directives and papers, every kind of information that I could get.
Very nice.
But I was still working in the thermal sector. Then in 2015, I moved to Lanco, which again was a hardcore thermal company, EPC company. But interestingly, Lanco had its own manufacturing of solar modules. So as part of that, I was in fact part of the team that was designing their new factory. So that was, you can say, my first hands-on brush with renewable. And of course, Lanco was already doing EPC of solar projects. So in those days, a 20 megawatt project is a very large size in 2016.
Yeah.
And that is when I got my hands really wet in solar execution. Then I spent 4 good years with SB Energy. SB Energy was a company belonging to SoftBank Group.
Right.
Subsequently, they sold it. But at that time, they were doing big things. You know, when rest of India was bidding at 50 megawatt sizes, SoftBank was already into 300 megawatt. And by the time I left, we were doing, thousands of megawatts of projects, including wind, solar, and of course, hybrid. And SoftBank also was experimenting. We had a lot of, innovation going on. I remember in many of our solar sites, we had this problem of dust. Dust means not just ordinary dust. The sandstorm used to come and suddenly your modules would be covered with a layer of sand.
Yeah.
So then we did a lot of researching, realized that quite a lot of the sand was coming up from local area. So then we studied the methods to suppress that soil. So we tried around 12 solutions. You won't believe, 12 solutions. Different kinds, like growing a layer of plants, like creating walls, like soil stabilizing layers, chemical treatment. So many methods we tried, actual experiments to prove, what really worked for us. I just gave that example, but we have done dozens of innovation studies, including new technology. In those days, robotic cleaning of solar modules was a pretty new thing.
Yeah.
I'm talking about 6-7 years ago.
Yeah.
And we had embraced that technology totally. We were doing literally hundreds of megawatts. Others had not started. Right? Similarly, trackers. Similarly, storage. Battery storage. 6 years ago, we already were operating our little battery storage along with our solar plant. Right? So that SoftBank experience, gave me a lot of new opportunity to experiment, to try new things, and all things, which I was beginning to love, because I could realize the benefit of renewable energy. But we will talk more about that, I hope.
Yeah.
Now, in SB Energy, for example, we were looking into the future. The owner or part owner of the SoftBank Group was somebody called Masayoshi-san. He was the chairman. And he had the vision. In fact, he was trying to convince Saudi Arabia, whose installed capacity was 70 gigawatts in those days. He was trying to convince them to do 100 gigawatt of solar. Right? So that is the kind of far thinking that he had. So I spent many months listening with the Saudi counterparts, a country whose entire economy was running on oil. We were persuading them to shift to solar. You can imagine
it's a transition.
The transition that, and today if you go to Saudi, if you look at Saudi, their entire current new industry, wherever they're spending money, it is on renewables, both in solar and wind.
Okay.
That is the extent to which that transition has borne fruit. Like that, we did some projects in USA, bid for some projects in Abu Dhabi. So it was a huge experience.
Very nice.
But when SB Energy was sold, then I moved to a company called Acme. Acme is a very old player in the solar industry. And the specialty about Acme was it was a single owner-driven company. Owner himself is an engineer. And he had this huge vision and forethought. When the rest of the world was just talking about hydrogen, he actually set up a pilot hydrogen project. Not a small one. It was around 4 megawatts size. It had its own solar plant. It had its own electrolyzer plant. and it had its own pocket-sized ammonia plant.
Mm-hmm.
So together, from solar, we could produce ammonia. At one stage, we were selling around 35 tons of ammonia per week.
Okay.
It used to go in a tanker to the neighboring fertilizer company, right? So based on that experience, we were able to design a very large 1 million ton per annum project, which is coming up in Oman.
Okay.
Right? So it was hands-on learning when others were still dealing with theoretical matters. Right? We were actually experimenting. In fact, when I joined, this plant had already been set up. But after that, then we did so many experiments.
And that was in 2018?
This was in 2021.
21.
Yeah. And we were doing experiments like, I was changing the transformers, the inverters, the rectifiers of the electrolyzer. We added battery storage and we were able to operate this entire plant separated from the grid. Right? So it was working as an island, its own generation from solar, a very small DG set, supported by battery storage. And it was able to handle all the variation of, solar. You can imagine a little cloud comes and your generation goes down to 10%. Right? So, and that was a huge game changer for us. Because Oman, where we were doing, the grid is so weak that, in fact, our plant was larger than the grid. So you can imagine any small disturbance from the plant would have collapsed the grid, right? So again, there we designed battery storage to stabilize the plant and keep it operating.
Very nice.
So this is the kind of experience that I had till date. But last 2 years has been my best years yet. I'm now an independent consultant, giving technical advisory on various fields. The entire power sector, renewable energy, green hydrogen, grid storage. I advise very small companies, very large players, helping them with their bids, with their technical problems in their plant. And I'm kind of enjoying this. It's like all that experience, but I'm doing at my own pace and only the jobs that I like.
Very nice. So, one perspective which I want to add here, maybe when we look at the overall energy as a sector, you started with the thermal power plant. And then when we look at the electrical energy or electrical infrastructure, we used to have the transition in terms of maybe the people liking the job opportunities from electrical, because electrical, mechanical, they were more like our green areas. फिर ऐसा हुआ कि इलेक्ट्रिकल और मैकेनिकल से लोग आईटी और सीएस सेक्टर में स्विच करना शुरू किए. फिर धीरे धीरे करके अब देखा जाए तो मैकेनिकल भी इलेक्ट्रिकल की तरफ शिफ्ट हो रहा है, और जितना भी एनर्जी सेक्टर है वो अब हाइड्रोजन, अमोनिया, रिन्यूएबल एनर्जी, ऑल सब सेक्टर्स में अब बहुत सारा ट्रैक्शन दिखता है. तो जितना एनर्जी सेक्टर में इतनी अभी बूम है, वो इवन जो आईटी सेक्टर का भी अपॉर्चुनिटीज, जॉब अपॉर्चुनिटीज थी, वो भी धीरे धीरे करके नाउ पीपल स्टार्टेड लाइकिंग द एनर्जी एज अ सेक्टर. आपको भी ये इतना ही विजिबल अट्रैक्शन दिखता है इस सेक्टर में?
Yes. In fact,
so this is very much like shifting, because you also have shifted from core electrical engineering or electrical power to renewable. So certainly this shift is natural, and this is certainly being perceived by so many maybe young professional also. So when you look at the opportunity in the shift or move as a sector, अब ये सेक्टर जिसमें हम लोग क्लाइमेट चेंज, एनर्जी, रिन्यूएबल एनर्जी, इन सब एरियाज की बात कर रहे हैं, वो सेक्टर बहुत ओपन भी हो रहा है, बिकॉज न्यूअर टेक्नोलॉजी आ रही हैं. जैसे आपने बताया कि हाइड्रोजन है, अमोनिया है, न्यूक्लियर है, ये सब सेक्टर्स में इतनी अपॉर्चुनिटीज हो रही हैं या होने वाली हैं. तो ये शिफ्ट विजिबल है आपके हिसाब से भी? डू यू वैलिडेट दिस शिफ्ट ऑल्सो, बिकॉज यू हैव मे बी आई थिंक इलस्ट्रियस 30 years ऑफ करियर, तो कहीं ना कहीं वो विजिबल सबको दिखता है या कुछ लोगों को दिख रहा है?
मेरे को तो अच्छा से दिख रहा है. बट वन थिंग, आई एम नॉट शिफ्टेड. आई एम स्टिल अ प्रैक्टिसिंग इलेक्ट्रिकल इंजीनियर. कल भी बहुत सारे कैलकुलेशंस करके आया था. सो आई वाज डूइंग सम रिले सेटिंग कैलकुलेशंस यस्टरडे. सो बट टू आंसर योर क्वेश्चन, if I were a new engineer today, it's no longer a confines of electrical or mechanical
Yes.
or instrumentation or civil. Today's engineer is an all-rounder in many fields, right? In my career, I've functioned as a civil person. I have to understand the civil methods. Similarly, instrumentation. Similarly, mechanical, of course, and electrical, without saying. But now people are getting, a combination of these core fields in their studies itself. They can specialize as only renewable energy engineer, right? Where they're taught about solar, wind.
Opportunity बढ़ रही है तो अपने आप मुझे लगता है कि
new fields are there. The only thing required as an engineer is effort and hard work. Okay. There are many fields where people immediately after college they want to become a manager, in charge of certain things. But 2-3-4 साल के बाद उनका depth बहुत shallow रहता है. Whereas a working engineer, he knows the system in and out. After 10-15 years, he becomes a manager, and his value is different compared to somebody who has just done an MBA, for example, or specialized in finance. Whereas this working engineer knows the system from in out, and it is more important today when technology is changing so fast.
तो मतलब नक्शल ये है कि जो अपॉर्चुनिटी बकेट है वो बढ़ गई है, right? So that is the intent.
I'd love to be an engineer, first year again.
Absolutely. One more question, sir. You also mentioned that कि जो size in terms of the infrastructure है वो बढ़ रहा है. You have also mentioned Tata Power का example लिया आपने कि पहले उस समय 200 मेगावाट का प्लांट या यूनिट चलता था. They took up this as a challenge and started on 500 megawatt. तो जब हम लोग इस तरह से जंप करते हैं from say 200 to 500, अब हम बात करें तो हो सकता है कि 500 से की बजाय वो 3000 4000 मेगावाट के भी प्लांट्स की बात कर सकते हैं. तो जब इस तरह की शिफ्ट होती है तो मतलब व्हाट आर द टूल्स एंड इंफ्रास्ट्रक्चर व्हिच आर रिक्वायर्ड? सर्टेनली एक तो विजन है क्योंकि फंडामेंटल फिजिक्स तो सेम है, बट जो रिक्वायर्ड एडिशनल टूल्स हैं, इंफ्रास्ट्रक्चर है, बिकॉज when you look at the infrastructure development and shift in terms of the size, it also requires a lot of conviction, confidence. और वो fundamental physics is one aspect. Certainly you always rely on this. But second aspect is whether you have the required tool to validate your calculations, to validate your conviction or vision. वो मतलब इंडस्ट्री में किस हिसाब से वो सब चीज़ें भी डेवलप हो रही हैं. जैसे आपने टाटा पावर का एग्जाम्पल लिया, क्या वो टूल्स और इंफ्रास्ट्रक्चर अभी अवेलेबल है? बिकॉज थिंग्स विल ग्रो फास्टर. हमारे यहाँ पर भी इतनी डिमांड रिक्वायरमेंट्स जो है तेजी से बढ़ रही हैं. सर्टेनली लॉट ऑफ इंफ्रास्ट्रक्चर रिक्वायरमेंट्स विल आल्सो ग्रो फास्टर. तो जहाँ पे हम मॉड्यूलर स्केल अप कर सकते हैं वहाँ पे हम शायद साइज में भी उसको बढ़ाएं. तो व्हाट आर योर्स मे बी योर टेक ऑन दिस?
I'd probably answer this at two levels.
Sure.
One is at the level of a company which is setting up projects. Like you mentioned, bigger and bigger projects. Let's talk about solar, wind, and grid storage. If you're doing large projects, you're scaling up. Very often the rules change. Right. What worked perfectly for a 10 megawatt plant, it will be totally infeasible. Exactly. If I'm doing a 1000 megawatt project.
Exactly. Yeah.
Okay. Look at the area itself. The project in Oman that I'm talking about, the 1 million tons per annum ammonia plant, the area itself is 100 square kilometers.
100 square kilometer? Wow.
Right. So you can imagine the kind of manual intervention which was there to manage a small plant. I cannot utilize the same method to manage the bigger one. Right. So that degree of automation, self alarms, self-healing, self-analysis, fault-finding, mitigation, all these have to be automated. So a lot of intelligence, you can call it AI, you can call it machine learning, is already getting implemented. And in the coming years, in the next 3-5 years, much more AI will go into this sector.
Okay.
In solar, there are literally a large plant, you could have lakhs of modules and strings, right? So one string fails to perform, you're losing something like 30 kilowatt of power, right? And no operator can manually track the performance of lakhs, right? So a lot of automation is built into the system. But that is at that level, right? Both in designing and in execution and in operation. We're using a lot of technology now, which is not available even say 5 years back.
Right. तो 5 साल में इतना शिफ्ट हो गया है.
Of course. For example, from a grid perspective, as a grid operator, grid operators in India are conservative because they've been operating a very stable 50 hertz system, thermal machines which would touch 500 megawatt and run on 500 megawatt continuously for months, or even more than a year sometimes, right? But today suddenly they are faced with solar and wind. Like I mentioned, one cloud and your solar goes from 100 megawatt to 10 megawatt. Wind stops blowing, your wind plant goes from 700 megawatt to zero in a matter of seconds or minutes. Right? And the grid operator used to hate it. Even now they hate it, but they're learning to live with it and use it. Okay? And so they forced a lot of conditions on power plant operators. They said, you have to predict your generation in the next 15 minutes, in the next 1 hour, in the full day, tomorrow, next week, you have to tell us your production. All right? So this is one area of weather prediction in the short term, which has become mainstream. Right. Now technology is available, service providers are available to give you real-time information almost. What's going to happen in the next 5 minutes, 10 minutes, 15 minutes. Then grid storage came. Then people realized, oops, grid storage is not properly covered in the regulations. Is it a generator or is it a consumer? Right? A basic question like that was not answered in the regulations because it is both a consumer, it is taking bulk energy from the grid and then it is giving bulk energy to the grid. Is it a generator or consumer? So that kind of things, starting from there, now the regulations are in place.
तो जैसे ऐसी चीजें मूव कर रही हैं वैसे लोग सीख रहे हैं.
Yes.
Both sides. रेगुलेटर भी सीख रहे हैं, सप्लायर भी सीख रहे हैं, डिमांड करने वाले लोग भी सीख रहे हैं, and that is how the infrastructure is getting built and becoming robust day by day.
So first one was infrastructure, दूसरा था regulations and all that. तीसरा है markets.
Demand
markets. So markets are now geared up to take. You can sell energy for tomorrow. You can sell energy for today. You can sell energy for now. Real time. Right? And it's all beautifully accounted. There's no mishap that, अरे मैं बिजली तो बेच दिया, but पैसा कहाँ से आना है? Who's to pay? So all that is beautifully set up. The next layer, the virtual generation, the virtual consumer. Right? So, for example, there is something called a virtual PPA. There is something called a aggregated PPA. There is a financial model where multiple small players, each one with a small home battery, they are aggregated using software and artificial intelligence and all that. And it behaves like, for example, like a 500 megawatt
battery storage
or a generation plant. So they deal directly with the utility. When the utility is, for example, facing low frequency, this distributed generation, which is now aggregated, is able to automatically pump in that 500 megawatt to the grid. Right? So that kind of what we call the ancillary services is now available today. So you can imagine the layers of growth that we've gone through. Infrastructure, regulations, the markets, the financial instruments and the tools you mentioned. Right? So all these put together is the ecosystem which in which renewable energy can just flourish. There is one last piece, which is manufacturing. Okay, this does not come easy because again, manufacturing of solar and electrolyzers for producing hydrogen, these are very, very capex intensive. The biggest success story there is our biggest competitor, right? You can guess it's China. China, for example, in 1 year is setting up more solar projects. In 1 year. I would say in 6 months, every 6 months, China is setting up more solar projects than what India has done
so far
till now. Right? So that is the scale at which they have taken this renewable energy. In fact, the USA has gone to China and complained, you're producing too much renewable equipment. You're making the price crash in USA. Right? So that is a level to which we have to go. Manufacturing. And it does not come easy. So India has taken the step that we will manufacture in India, Atmanirbhar Bharat. That scheme, the program is driven by the government. There are a lot of pain points. Why a lot of pain points? As a power producer, I am very happy buying in China or Vietnam or Malaysia. I get very high quality equipment, very high efficiency with all the experience, right? By experience, I mean the similar product is already in operation for the last 3 years, 5 years. Whereas somebody producing in India today under Atmanirbhar Bharat is giving me relatively old technology, maybe 1 year, 2 year old technology. And that technology has not had the hardcore experience. How does it perform in the field? Does it degrade normally, like any solar module will degrade? Or is it degrading suddenly and losing its life? Same with battery. Right? So it's a big pain point for an Indian IPP to stop buying from China and buy from a new company in India. Right? But we're doing it under compulsion, under a lot of push and pressure. The Indian industry has responded. Now it is scaling up by the way, interestingly, India was already exporting to the USA even 5 years, 10 years back. Solar modules.
सर इसमें एक पर्सपेक्टिव और मैं इसको ऐड करता हूँ. जैसे हमारे कंट्री पर्सपेक्टिव है कि नेशन में इस तरह का गोल, क्लाइमेट गोल स्टैब्लिश किया गया है हमारे ऑनरेबल प्राइम मिनिस्टर के थ्रू कि हम लोग एज ए नेशन 2070 में कार्बन न्यूट्रल कंट्री बन जाएंगे. नेट एमिशन जो है हमारा 2050 में वो 0 हो जाना चाहिए. Correct. और इस तरीके की जो इनिशिएटिव्स हैं वो सच पूरे नहीं हो सकते जब तक कि पब्लिक सेक्टर, प्राइवेट सेक्टर, ऑर्गेनाइजेशंस अपने आप में इनिशिएटिव लें और वॉलंटरी इनिशिएटिव भी आना चाहिए कंपेयर टू द मे बी कंप्लायंस बेस्ड इनिशिएटिव. और वहाँ पे डिकार्बोनाइजेशन एज ए प्रोसेस को लोग एम्ब्रेस करें और आगे बढ़ें इन टर्म्स ऑफ योगदान देने में कि कंट्री का एक विजन है उसको हम लोग कैसे पूरा करें. नाउ इन दिस पर्सपेक्टिव जब हम लोग डिपेंडेंसी ऑन द मैन्युफैक्चरिंग है, इंपोर्ट इश्यूज हैं, इस तरह के इश्यूज को क्योंकि सब कुछ जो भी ड्रिवन है वो एक टूल्स, प्रोडक्ट, कमोडिटी इन सब से ही गवर्नड है. क्योंकि एनर्जी सब तरीके से आनी ही आनी है बिकॉज फॉर एनीथिंग और एवरीथिंग यू नीड द एनर्जी. और वो एनर्जी प्रोड्यूस करने के साधन अब वो क्लीन एनर्जी के फॉर्म में होने, और क्लीन एनर्जी की जो मैन्युफैक्चरिंग है वो डिपेंडेंस है ऑन लेट्स से सेल. अगर स्टोरेज की बात करें तो अगेन वहां पे डिपेंडेंसी है, या किसी और इस तरह के फॉर्म में डिपेंडेंसी है. तो डिपेंडेंसी सर्टेनली वन नेशन टू अनदर नेशन एक बायलैटरल बिजनेस एग्रीमेंट्स या ट्रेड्स के थ्रू चलती है. बट वी ऑल्सो हैव सीन कि वो चैलेंजेस हो सकता है कि अभी ठीक हैं, हो सकता है बाद में खराब हो. इस तरह की डिपेंडेंसी जब होती है और डिपेंडेंसी अनसर्टेन भी होती है कभी कभी, उस तरह केसेस में कंपनीज पर्टिकुलरली प्राइवेट सेक्टर व्हिच हैज डिसाइडेड टू इन्वेस्ट इन अ पर्टिकुलर सेक्टर, वो कहीं कहीं वो रिस्क बहुत ज्यादा विजिबल दिखता है.
राइट.
है ना. So how do you see I think organizations' role and their responsibilities in terms of meeting the initiatives requirement कि हम लोग डिकार्बोनाइजेशन का जो विजन है उसको कैसे पूरा कर सकते हैं और इस तरह के रिस्क को कैसे मिटिगेट करें?
For an organization,
जी,
right? Firstly, they are responsible to their shareholders. So they have to make money. They cannot. So that is their primary
margin बनाना.
Yes, margin.
First important
reasonable profit. The second important thing is, of course, they have to comply with all the ecosystem requirements like clean energy and whatnot, right? But here's the beauty of it. Here's the beauty of it. Today, you don't need compulsion from government or any UN body to transition to clean energy. It is already cheaper, right? Today, if I'm setting up a new thermal plant, the cost of energy coming from that plant could be of the order of 6 rupees, 7 rupees. Coal plant, right? Cost of per kWh is going to be 7 rupees.
I agree.
Along with all the other costs, the cost of that energy coming to your doorstep in the industry would be something like 10 rupees, 12 rupees. Whereas today, solar, wind and storage, today, we are able to give round-the-clock energy at a discovered tariff of the order of 5 rupees, 6 rupees. Okay? So that means already for a company, it makes sense to buy renewable energy compared to thermal.
Market shift ho raha hai because of the price.
Why won't you do it? Right? So there is no compulsion from anybody. They can very well voluntarily do it. It only requires the management to be proactive, to make the mind shift. I give energy as an example, the input energy, but so many other areas the shift is possible. Can I take 5 minutes on that topic because it's a favorite topic of mine?
Sure.
Right. Very briefly, why decarbonize? Because of global warming. Why global warming? Because of climate change coming from the effect of greenhouse gases. Greenhouse gases acting like a blanket around the earth, trapping some of the sunlight inside. So gradually we are heating up. Unfortunately, even a small heating, say 1 degree temperature change in the ocean temperature, which is 1 degree, is making a huge difference in our weather. You get very heavy rain, you get very heavy drought, you get very heavy storms. So everything has become more violent. The weather has become more harsh and violent just by a 1 degree change. Okay, the world has promised to its future generations that we will limit this temperature rise to 1.5 degrees. This happened in the Paris Agreement, which was in 2015. All the countries of the world, most of the countries, and they all agreed that we will limit the average temperature rise to 1.5 degrees, and we will do whatever is necessary to make this happen. Okay, so all countries said we will give our NDCs, nationally committed targets. Okay, so those targets could be, for example, India said that by 2030 our emission will go down by 45%. Emission intensity of the grid. So it is not absolute 45%, but corrected for GDP with respect to a baseline of 2005. Okay. Similarly, we have committed to transform, to grow our renewable energy to such an extent that in a few years, our grid will be 50% non-fossil. The heating of the earth is happening because of these global greenhouse gases, GHGs. What are these gases? Carbon dioxide, methane, nitrogen oxide, some chlorofluorocarbons, like the kind that goes into an air conditioner.
CFCs.
Interestingly, water vapor also. But the biggest culprit is carbon dioxide. And each one has a different effect on the global heating. If you take carbon dioxide as reference, methane has almost 30 times the effect of carbon dioxide.
Right.
In heating potential. The nitrogen oxides have around 250 times. So 1 ton of nitrogen oxide damages equal to 250 tons of carbon dioxide.
CO2, yeah.
CO2. Similarly, the other fluorocarbons, their effect is in thousands of times more than carbon, CO2. But in terms of volumes, it is CO2. CO2 is produced by every human activity. You may think it is only power plants which are emitting CO2. No. It's coming out of your car, it's coming out of your scooter.
Everything.
It's coming out of the fuel that you burn in an industry. It's coming from a cement plant in the chemical process.
We also exhale CO2.
In fact, that is one of the biggest contributors, agriculture, farm animals, because there are millions of them. The CO2 that they exhale, in fact, the methane that they exhale, has got a significant proportion of greenhouse gas contribution. Rice production, interestingly, just the act of producing rice, growing rice, because in paddy fields the water is standing and there is a lot of vegetable matter there. The rotting that takes place gives rise to methane, which contributes around 1.5% to global greenhouse gas per year.
Yeah. It's a huge
So every human activity is contributing to greenhouse gas. There is a protocol called the Greenhouse Gas Protocol. It's basically a international organization which is set up, the means of measuring your contribution to the greenhouse gas. For example, your family could calculate in a year how much greenhouse gas am I producing. Very easy, the formulas are there. The electricity that you consume in India, that electricity is worth something like 700 grams of CO2 per unit of electricity. So as a family, suppose you're consuming say 5,000 units in a year, you can calculate 5,000 into 0.7 kgs. That is a kg of CO2 you're producing in a year. If you run a car, so many grams per kilometer, right? If you're taking water from the municipal supply, that also has a CO2 associated with it. Because the municipal supply is using up energy to treat the water, to pump the water, right? So every human activity can be measured in terms of CO2. This is what companies do. There is something called Scope 1 emission, which is what they do in their day-to-day operations, including burning of fuel. Suppose you're running your company car, or you're burning a fuel to produce something. All those activities. Scope 1. Scope 2 is all the energy that you buy. You buy energy, you buy electricity, you buy
from the grid, or
you buy heat, you buy steam for your industry. The carbons associated with that is Scope 2. Scope 3 is everything else. You can imagine Scope 3 is very often outside the area of your influence. Your contractor, your subcontractor, what is the carbon that he's producing? Your consumer, suppose you're making television sets. That consumer is consuming,
distributing the telephone.
Is creating carbon there. So all those secondary emissions coming from your external contact points. So all those are Scope 3. So all these are to be accounted and reported by every country, every company. Of course, there is a term called greenwashing. You can imagine it's not a good term. People will falsely declare. Why? Because investors, lenders, they're all looking at these numbers, regulatory bodies.
I think organizations in general perspective, I think, जैसे greenwashing का आपने नाम लिया, I think there might be a lesser percentage, 2-3-5% of them might be doing it. But वो धीरे धीरे जैसे ही monitoring बढ़ेगी और lenders की अपनी एक responsibility है to validate the expenditure और उस तरह की चीज़ें जैसे ही बढ़ेंगी, मुझे लगता है कि ये सब चीज़ें जो ग्रीन वॉशिंग कंपोनेंट है वो भी हो सकता है बढ़े, बट इन जनरल जो इंटेंट है ऑर्गेनाइजेशंस का इन टर्म्स ऑफ फॉल्सिफाई क्रिएशंस, वो शायद अपने आप धीरे करके कम हो जाएगा.
But there are a lot of things company can do, right?
जी.
First step, measure. I gave you the example of a family. I would strongly advise every youngster out there, try doing a calculation. You will be surprised how much CO2 you're dumping into the system. All right. So first step, measure. As a company, first you measure. The second step is to look at your scope 1 emissions and scope 2 emissions. There's a lot of things you can do about scope 1 and scope 2. First, and India has made a head start in this. First is to look at efficiency of your operations. Again, Bureau of Energy Efficiency has worked wonders in the last 15-20 years. And every unit saved is a unit generated, and it is earned. You're saving CO2, right? If I can improve my efficiency by 10%, that much by 10% my CO2 is reduced, right? So world is producing something like 50 billion tons of CO2 every year. That 10% automatically means 5 billion tons is gone, right? So first step, efficiency, and beautifully your organization, Green Tree, the entire group is deeply into energy efficiency in all its forms. And so you're contributing to CO2 decarbonization.
Thank you so much, sir.
So first step is efficiency.
Right.
Second is reducing your consumption. Right? There are various ways to improve your processes and systems and reduce. The third is to transition to renewable energy from fossil fuel based economy. I'm not talking about just the electricity that you generate, but also that the fossil fuels that you fire in the process. That's where many industries like steel industry is now seriously looking at using green hydrogen.
Steel, cement,
yes,
जो heavy industries हैं उनको requirement है ही है इंडियन में.
Yes.
तो इसमें सर क्या, जैसे कि जो heavy industry उनके लिए compliances path है, they'll certainly move towards such aspects जो कि cleaner fuel की तरफ है, या energy transition को उनको adopt करना एक government की requirement बन ही जाएगी धीरे धीरे करके. इसमें एक दूसरा aspect भी है कि जब हम लोग छोटी इंडस्ट्रीज की बात करते हैं, जैसे आपने स्कोप 1, स्कोप 2, स्कोप 3 बताया, सर्टेनली ऑर्गेनाइजेशंस धीरे धीरे करके उस न्यू लैंग्वेज को अडॉप्ट कर लेंगी, बट जो छोटी ऑर्गेनाइजेशंस हैं, एमएसएमईज या इवन स्मॉलर एसएमईज, बॉर्डर लाइन वाली, और पर्टिकुलरली फॉर द एक्सपोर्ट ओरिएंटेड यूनिट्स, जब हम लोग सीबैम की बात करते हैं, तो जैसे आपने सुना ही होगा कि ईयू या यूरोपियन यूनियन ने रिसेंटली उन्होंने कार्बन बॉर्डर एडजस्टमेंट मैकेनिज्म करके उन्होंने एक लॉ या रूल निकाला है, जिसका मैंडेटरी प्रोविजन जो है 2026 से शुरू हो जाएगा. अभी वॉलंटरी है. और इस तरीके के जो टैक्स कंपोनेंट है या मैकेनिज्म है, इट मे बी आई थिंक इट मे इम्पैक्ट अ लॉट टू दोज इंडस्ट्रीज जिनका एक्सपोर्ट ओरिएंटेड बिजनेस है, मैन्युफैक्चरिंग इंडिया में कर रहे हैं और एक्सपोर्ट बाहर करेंगे. और उस तरह के जो एजेंसीज हैं या जो मैन्युफैक्चरिंग यूनिट हैं, जो इंडियन सिस्टम के हिसाब से अभी वो कंप्लायंस पाथ में नहीं आती हैं, बट सर्टनली जब बिजनेस पर्सपेक्टिव से देखते हैं तो उनके लिए वो मैंडेटरी रिक्वायरमेंट हो जाती है. तो हाउ डू यू सी देयर मे बी आई थिंक रिसेप्टिवनेस इन टर्म्स ऑफ एडजस्टिंग देयर बिजनेस रिक्वायरमेंट विद रिस्पेक्ट टू स्कोप 1, 2 and 3 विद रिस्पेक्ट टू सीबैम और सच अदर रूल्स रिक्वायरमेंट और कंप्लायंसेस मीट करने के पर्सपेक्टिव से? आपको लगता है कि दे आर प्रिपेयर्ड एज ऑफ नाउ, और डू दे नीड मोर टाइम टू गेट प्रिपेयर्ड टू मीट सच रिक्वायरमेंट्स? क्योंकि सीबैम एक जगह लगा हुआ है, ऑल्दो ये डिबेटेबल है, बहुत सारे कंट्रीज पर्टिकुलरली साउथ एशियन कंट्रीज उसको विरोध भी कर रही हैं, क्योंकि हमारे यहाँ पे वो एक तरीके का एक डिटरेंट है इन टर्म्स ऑफ बिजनेस पर्सपेक्टिव से, और कुछ लोगों के वहां से उनकी इस रिक्वायरमेंट पे है, एंड दे आर अर्निंग लॉट ऑफ मनी फॉर द नॉन कंप्लायंसेस ऑल्सो. So that is where maybe I think there is always a debate going on. But I think look at the brighter side in terms of how such small companies can meet those compliances. और वो शायद लॉन्ग रन में कंट्री को भी फायदा करेगा. अभी तो बिजनेस के लिए रिक्वायरमेंट है बिकॉज दे हैव टू सर्वाइव, दे हैव टू सस्टेन एंड दे हैव टू मीट दोज compliances. Do you see that there is a silver lining and the positive receptiveness among those smaller industries also?
Yeah, I'll come to that.
Yeah.
Firstly, briefly about CBAM.
Yeah.
Look, Europe is forcing its own industries to transition. Okay. So the way India is doing through Bureau of Energy Efficiency, Europe is doing much more to force their own, for example, steel making units to become more decarbonized. So more cost of steel for the local guys. So in this context, if somebody from India or China or Korea were to dump their steel into Europe, then the local steel fellows will go bankrupt.
Yeah.
Right? So it's a simple logic that they have to create a tax at the border entry so that, the level playing field is guaranteed for their local guys. Today, India is contributing something like less than 3 billion tons of CO2.
Okay.
You remember in the world, I said we are generating around 40-50 billion tons. Right. So India, with its very large population, is contributing only less than 3
billion tons of CO2.
China is around, say, 8 to 10 somewhere.
Yeah.
USA is something like 6-7. Europe is 6-7 and so on. So India might say, look, per capita is very less. Per capita is very less. Why should I do anything at all? If you calculate on a per capita basis and compare India and USA, our population is 4 times. Our contribution is 1/3. So per capita basis, an Indian is contributing 1/12 of what an American is contributing in terms of carbon. We could say, look, it's not my game. Unfortunately, we're all sailing in the same ship and that ship is sinking. Today, that ship is sinking. We are not yet bothered by it on a day-to-day basis. We tolerate the violent climate. But the day will come in a few more years when that climate change will become unbearable. Last year, the heat in Delhi was, this year, in fact, heat in Delhi was unbearable compared to the previous year. In a few more years, you may not be able to come out of your house on certain days. You will tolerate that. But in a few more years, our children, their children, will point fingers at us. They will say, why didn't you do something when you had a chance to do it? But to say that we cannot do something, that is not on the table any longer. Everyone has to contribute. Every MSME has to contribute. I feel so sad if I see some vehicle who's emitting smoke on the road. It's so easy to fix it. Right? So every person who's driving a car has to contribute. Meaning you have to go from fossil fuel car to hydrogen car or a EV. Or take a bus or take a tram or take a metro. Right? But you have to do it. That message has to go down to every school, every organization, every MSME.
Very nice. So, मतलब message ये है, which is very clear and loud, that even if it is a small industry, they have to look around and find the solution out in terms of decarbonize their processes and meet the expectation. Even if it is CBAM as a maybe specific criteria which is levied on the exporters from India. So that is something that maybe I think the initiative has to be taken up with a positive sense. Right?
This has to come from the government. You see, without a policeman, people don't obey traffic rules. It's a fact. So without a policeman, without enforcement, without measurement, your average MSME also would like to think, look, I'm just contributing a little bit of water in that pool of milk. Coming from the Akbar Birbal story, right? So they will always think, chalo, mera contribution na रहने से भी हो जाएगा. नहीं, that policing, that enforcement has to be done. It's a matter of governance. Any government, state, district, central, who's not doing this, I'd say they're not doing their job. Right? And Government of India is doing a lot in this direction. Much more enforcement required at the district levels, at the state, at the taluk level.
बूंद बूंद करके सागर बनता है.
Yes.
तो कंट्रीब्यूशन तो इम्पोर्टेंट है ये सब.
हर एक का आना.
Some rapid fire questions हैं. एक तो क्वेश्चन है कि मतलब one gadget that you have yourself, you can't live without that. ऐसा कोई गैजेट है जिसके बिना आप नहीं रह सकते हैं?
जी हाँ. It's not a modern gadget. It's in fact my pen.
Pen, okay.
I cannot live without this. Even if I'm going on a picnic, I have a pen and a piece of paper there in my pocket. Because once the thought comes, I have to immediately write it down. Later on, I can process it, analyze it, to take actions. But I love to jot down and...
Very nice, very nice. तो एक कोई मतलब एक the most exciting innovation आपको लगता है, क्योंकि आप renewable energy कितने सालों से काम कर रहे हैं, आपको लगता है कोई ऐसी innovative technology है जो आपको बहुत excite करती है, आपको लगता है कि this will go long way?
आज के दिन में it is energy storage.
Okay.
In college we were taught electricity is produced, it has to be consumed in the same instant. It cannot be stored. This is what we were taught. Today, if not electricity, I can store it in other energy forms. Right? Say chemical energy in a battery, or gravitational energy in a pump storage, potential energy when I'm compressing a gas like air or CO2. So a lot of storage technologies are there which are commercially viable and demonstrated.
Okay.
Right? You just have to go and set it up.
And apart from storage, कोई ऐसी technology आपको लगता है कि the next decade will be of this technology?
Hydrogen. Few years ago, we said it had a lot of promise. Today, that promise has come true. The next step is to large scale it, to mass utilize.
Okay. Very nice. So and what is your work philosophy? In short form.
I've worked for 36 years.
Yeah.
Right? So now I told you I'm loving what I'm doing. And my philosophy is very simple. I do what I love. I work in only those areas. I told you I do relay setting calculations. I love doing that. Right? Hands-on engineer.
Very nice. So coming to maybe I think आपने एक point बोला जैसे hydrogen as a technology will be the next decade's technology. इस टेक्नोलॉजी पे थोड़ी सी बात करते हैं. मतलब ये टेक्नोलॉजी बहुत प्रॉमिसिंग टेक्नोलॉजी है और मतलब गवर्नमेंट हो, इंटरनेशनल एजेंसीज हो, वो लोग बहुत बेट ले रहे हैं. हाउ डू यू सी दिस टेक्नोलॉजी एंड मतलब क्या उसमें चैलेंजेस कहाँ पे हैं इन टर्म्स ऑफ स्केलिंग इट अप? आपको मतलब गवर्नमेंट बुलिश है अभी, लॉट ऑफ मे बी पॉलिसीज बन रही हैं स्टेट लेवल पे इन सब चीजों को लेकर के, बट कोई चैलेंज भी आपको परसीव करता है?
Yeah, of course. Lots of things to be done. Firstly, hydrogen itself is not new. Right? People have been using it for hundreds of years. And India is already, I think, around 6 million tons of hydrogen is being used in India. 600 million? 6 million tons.
Okay.
And all of it, or mostly all of it, is produced from hydrocarbons. It is coming from, natural gas or coal, right? The problem is when hydrogen is produced from these things, it gives rise to a lot of CO2, lots of CO2 and methane. And then where are you? You've gone into carbonization, right? So currently hydrogen is used in refineries in the process. It's used in fertilizer industry to produce ammonia. And that hydrogen is combined with nitrogen to produce ammonia, and ammonia is used to produce various fertilizers like urea. All that hydrogen is called grey hydrogen. It's coming from fossil fuel. It's already done a lot of dirty work, carbon work. So we call it grey hydrogen. What we call green hydrogen is that hydrogen which is produced by electrolysis from renewable energy. If I used ordinary grid electricity, I told you it has got around 700 grams of CO2 per unit. That is no use. That hydrogen is still grey, even though I'm using electrolysis. But if I use electrolysis and if I take that electrical energy from solar and wind,
also compare
$1.5
with respect to the thermal plant or with respect to renewable energy. So let's say you mentioned...
Oh, that's the unfortunate part. Grey hydrogen, which is produced from fossils, is costing much less than $3. So that is one milestone which has to be crossed by green hydrogen to become cheaper than grey hydrogen. That is going to happen in the next decade or so.
Okay.
Two things. One, the cost of renewable energy is falling all the time. Two, the cost of electrolyzers is again falling because of large scale use. So economy of scale is working in favor, and the efficiency of electrolyzers is being improved. Their life is being extended. Otherwise, they used to fail after a certain number of years. So all these factors will lead to a much reduced price of hydrogen. The target for everyone is to have price of hydrogen which is less than $1 per kg of hydrogen.
$1 per kg of hydrogen.
I'll give you some numbers.
Yeah, sure.
To produce 1 kg of hydrogen, I have to consume something like 45 to 50 units of electricity.
45 to 50 units of electricity.
KWH. Apart from the capex of the plant and the other, other operating expenses. So cost of input energy has to go down. The only way it can go down is through renewable energy and storage.
Yeah.
Long way to go, but that is the target of everyone.
One more thing, sir. It is also heard that maybe the storage is also one challenge. It is not that it can't be done, but the bulky storage for the hydrogen plant which is required into storing the energy is also one of the deterrent, because you cannot just maybe I think you produce and transfer. You have to store it for some time and then you have to transfer. Is this something that also a challenge in terms of maybe I think exporting? You mentioned that export is also one of the vision that the India is eyeing for in due course of years, because captive plant laga karke utilize karna is something which is always meaningful. But agar export karna hai to storage will be the challenge.
Absolutely. Hydrogen is called an energy carrier. For example, like electricity or petroleum or petrol, right? Unfortunately, it's a very light gas. So the energy density of hydrogen is very, very poor. And for that reason, even cars, it is very difficult to transition to a hydrogen car. The technology is already there. Convert hydrogen using fuel cells, you get electricity, you run the car. Problem is the amount of hydrogen that you carry on board. You have to compress it quite a lot. A lot of technology challenges associated with storing of hydrogen. Even, ordinary steel becomes brittle when pressurized hydrogen is stored in it. So I have to have a special coating inside and stuff like that. So there is a technology challenge in terms of, effort and cost. The other thing is, like I said, the density is still very poor. So if I'm exporting hydrogen, it is never sent as hydrogen. I convert it to, for example, ammonia. Ammonia is very easy to transport. Today, there are thousands of ships already running across the earth carrying conventional ammonia. For example, Japan imports a lot of ammonia. Europe imports a lot of ammonia. So India's business model would be produce hydrogen near a port, convert it to ammonia, have ammonia storage containers in the port, bring a ship, load the ship, send it across. In fact, interestingly, in my previous project, we worked on storage of hydrogen underground. in so-called salt caverns.
Okay.
So underground, 3 kilometers below the earth, you have salt in solid form. You can imagine this room filled with salt. So we pump water, take out the water, salt comes out. What is left is a cave under the ground. Then we pressurize hydrogen into it and store it. This is a well-proven technology. USA and even India in some places is storing natural gas in underground caverns, and that is a strategic storage. You can store millions and millions of tons of this stuff. And tomorrow, if there is a disruption, global disruption, say a war in the Middle East, USA can run for several months with the energy that they have stored. Right? So underground caverns, that's one way of doing it, and that's the cheapest form of
storing
hydrogen storage on a per ton basis.
Wow.
Right? But like I said, chemical storage to convert to ammonia and store. But when I'm designing a hydrogen plant, I need this hydrogen storage in steel containers. But more and more, I can store it in electrical form. Like I said, my solar produces in the daytime. I could use wind in the nighttime. Beautifully, wind blows more in the night. Solar is during the day. So together, they give me energy, renewable energy, more around the clock. I add a bit of storage, battery or any other kind of storage. So I get a reasonably steady flow of energy around the clock.
Okay.
So my capex of my electrolyzer is reduced because now I'm running my electrolyzer for 24 hours. Previously, I was running it only for 8 hours. So overall, my cost of hydrogen production is coming down. So that is one kind of storage. People use grid storage, which is basically giving my solar energy to the DISCOM and taking it from the DISCOM in the night. It's like banking, grid banking.
Right.
So there are many levels of storage. Each one has its benefits and disadvantages.
Very nice. Okay. Sir, just to maybe I think break down one decarbonization case study or process for let's say small industry, because ज़्यादा challenge वहाँ पे है. अगर किसी small industry को decarbonization action plan बनाना है, तो सबसे पहला step तो यही है कि अपने यहाँ की जो energy consumption data है वो measure करे और उसके बाद जो avenues जो energy consume कर रहे हैं उसको efficient बना ले. And this comes under the energy efficiency component. तो वो renewable form में नहीं है, but that is the most maybe I think effective form of energy. तो वो energy efficiency पहले implement कर ले और फिर वो renewable energy की form को integrate कर ले, चाहे वो RE की form में, solar की form में हो या let's say हाइड्रोजन के फॉर्म में हो, अमोनिया के फॉर्म में हो या इस तरह की कोई भी जो टेक्नोलॉजी अवेलेबल है उसकी फॉर्म में हो. दैट इज द मे बी आई थिंक 3 स्टेप प्रोसेस है ना. डेटा कलेक्शन है, एनर्जी एफिशिएंसी है और फिर रिन्यूएबल एनर्जी इंटीग्रेशन है. इस स्टेप में एनर्जी एफिशिएंसी अपने आप में चैलेंजिंग टास्क है. बहुत सारे जगह पे या इंडस्ट्रीज में वो इंटीग्रेट करना बहुत बड़ा मुश्किल काम है क्योंकि वो दिखता नहीं है. और जबकि रिन्यूएबल एनर्जी कंपोनेंट क्या है कि वो विजिबल है, वो आपकी छत पे लगा हुआ है, आपके या तो गोडाउन में लगा हुआ है. तो दैट इज समथिंग वेयर इंडस्ट्रीज काउंट इट एज ए टैंजिबल इन्वेस्टमेंट और उसको वो इनिशिएटिव लेने में कोई डिटरेंट नहीं है कंपेयर टू द एनर्जी एफिशिएंसी. तो ये जो अवेयरनेस है इन द इंडस्ट्रियल डेवलपमेंट, क्योंकि हम ग्रो कर रहे हैं, तो अगर हम अपने एनर्जी एफिशिएंसी कंपोनेंट को पहले इम्प्लीमेंट नहीं करेंगे तो शायद कहीं ना कहीं वो अभी बढ़ता जाएगा और एनर्जी कंजप्शन बढ़ता जाएगा. चाहे आप रिन्यूएबल एनर्जी इंटीग्रेट कर लें, बट सर्टेनली इट इज नॉट द ट्रू वे ऑफ टू डिकार्बोनाइज द इंडस्ट्री.
करेक्ट
है ना. तो ये जो प्रोसेस है उसको कैसे इंडस्ट्री को कैसे अवेयर कराएं कि एनर्जी एफिशिएंसी इज वन ऑफ द बेस्ट मेथड टू मे बी आई थिंक टू डिकार्बोनाइज देयर प्रोसेसेस.
आई थिंक they can do it in two stages. Initially, they should get an external third party, right? Learn the tricks. 1, 2, 3, 5 years. And then they continue the good work. right? The first step is, like you said, measure. Even if you're doing an energy efficiency project, the first step is to set up a baseline. Baseline means you observe your consumption for 6 months, historical data. Okay. For producing so many meters of cloth in a month, I used so much energy. A simple baseline number. If I'm producing, cloth. That baseline number is very important. Corrected for, variations which could come from different type of products, product mix, seasonal variation, all those things. Then attack, the low-hanging fruit. 80%, 20% rule. Attack the areas where you get immediate benefits. And energy efficiency is the first one. And then again, look at the baseline numbers. Show that it has improved.
Right.
And today, people are paying you for it. You can earn carbon credits if you prove that you have taken measures where you have reduced your emission, right? So you're getting carbon credits. It's a little laborious process, which is why I said third party. But you can earn money from such an operation, right? The second step is more difficult after going beyond efficiency improvement, which is again to target all your known sources of emission. Now we're talking about decarbonization.
Right.
So it could come from electricity is very easy to measure and visualize. Even some companies calculate the commute of their employees. ऑफिस से कितना दूर पे रहते हैं, अपना अपना गाड़ी लेके आते हैं,
या कारपूल करते हैं, या पब्लिक ट्रांसपोर्ट
कारपूलिंग करते हैं, या कंपनी के बस चलाए तो शायद ये कम हो जाए. They're all coming from Noida to Meerut, let's say. I'm just giving an example.
Yeah.
Every day, some people commute from Meerut to Delhi.
Absolutely.
If my company bus can come from Meerut to Noida every day, so many two-wheelers and cars are replaced by a single bus. If I can run the bus on EV, again a reduction, right? Is tarika, every area has to be targeted. Not just my fuel that I'm using in my plant. Okay. That will give you 50, 60, 70% improvement. Remaining 30%. What is my contractor doing? वो किस टाइप का गाड़ी लेके आता है, उसका पोल्यूशन अंडर कंट्रोल सर्टिफिकेशन है क्या, or is he using some old technology vehicles which can be improved? Can I give him a soft loan with some conditions and he goes to it?
हाँ, मतलब आई थिंक वो अवेयरनेस और क्लैरिटी मिल जाए जितनी जल्दी. द बेस्ट मेजर दैट वी हैव सर नोटिस्ड इन द इंडस्ट्री कि एक इंडस्ट्री जो मोर पोल्यूटिंग है, अगर वो बगल वाले को देखती है कि उसका लेस पोल्यूटिंग हो रही है, तो शायद दे कैन एक्चुअली लर्न फ्रॉम द नेबरहुड पीयर, and that is the maximum, maybe I think, contagious adoption that we have noticed when we go to the site or to the ground in terms of you're discussing with the MSMEs or SMEs in terms of their decarbonization action plan.
It has to be part of the language.
Right.
You see, आपका गाड़ी कितना किलोमीटर देती है? Very easy to understand. Right? You say 12, I say 20. Somebody is at 8. 8 kilometers per liter of petrol.
Yeah.
Right? So that kind of conversation should happen with MSMEs. What is your carbon consumption?
Thank you so much for a lot of, maybe I think, passionate messages to our listener. Maybe I think the last message that I can request for our maybe I think young fellow entrepreneurs, or for maybe I think young professionals, कि वो अपना करियर या अपना बिजनेस मे बी एनर्जी एज ए डोमेन में बनाना चाहते हैं, तो वो कैसे बनाएं? मे बी सम स्पेसिफिक टिप्स फ्रॉम योर साइड.
India has become a hotbed for entrepreneurs, right? So the sky is the limit. If you are willing to think and put in the hard effort, right? So very much all fields are open. There are no experts here. Everyone is learning about hydrogen storage and so on. So very quickly, a small startup can become, a leading player. For those who are not entrepreneurs, I'd strongly advise the studious ones to go ahead, complete your doctorate, do research, because this is where we lack a lot as a country. China, one company, he's got a board in the entrance. He has written down the names of all his PhD, R&D scholars. Hundreds of them in one company.
So that is
you imagine how many companies
showcase
have
style.
Yes,
Yeah.
yes. They are proud of it. India has to bring that pride. Today, people will say, "Why इतना मेहनत क्यों करें? 7 साल पढ़ाई करके डॉक्टरेट बनना है बाद में गवर्नमेंट का सैलरी लेके कौन बैठे?" Right? So that mindset has to change. And there are exciting fields in which to do research. Right? So I'd strongly advise both those cases. One, hardcore research. The other, go deep into engineering, applied engineering, setting up industries, manufacturing things, producing hydrogen, producing solar energy, helping others do this. So the field is wide open. It's an exciting time that we live in. Never before has the world done such a big transition in such a short time.
Very nice. It is the biggest opportunity. I totally agree with you. And this is maybe, I think, the next 10 to 20 years, we see that not only the market, but maybe I think the individual will also grow very fast. And when I say entrepreneur, I'm actually saying that the entrepreneurship as a feeling, as a, maybe I think, a spirit that every professional should have. And that is where maybe I think you can always learn faster and you can grow faster as well. So thank you so much, sir, for coming here, joining with us, and sharing your thoughts. I think a lot of learning for our listeners here, and we really thankful to you for sparing your time with us. Thank you so much.
Thank you. I loved doing this.
Thank you.
My favorite.